Hello, this is Elizabeth Shumagawa from the Academic Support Center at Raritan Valley Community College. Today we just wanted to talk a little bit about equations in quadratic form. So you'll recall that quadratic equations look something like ax squared plus bx plus c equals 0. But we can have terms that have such as this, that have x to the fourth minus 4x squared minus 12. So as long as this leading term is the square of this term, we can treat these just as quadratic equations and factor them and solve them in a similar manner. So I just wanted to go through a couple of examples. I'm going to move this down so we have some space to work. So we have x to the fourth minus 4x squared minus 12 is equal to 0. So what we need to notice is that our leading term is x to the fourth, and this term is x squared. So the first term is the square of the second term. So this could be x squared, x to the fourth. It could be x cubed and x to the sixth, or x to the fourth and x to the eighth. As long as this exponent is 2 times this exponent, we can treat it as a quadratic equation. And the simplest way to do this is that we want to do a substitution. We want to say that u is equal to x squared. So we can rewrite this equation. This is x squared squared, because when we put our exponents to the power, we're going to multiply. Minus 4x squared minus 12 equals 0. So now we're set to do this u substitution. This becomes u squared minus 4, well, x squared is u, so that's u, minus 12 equals 0. And now we can factor this. This looks like something we can factor. This becomes u. We have to ask ourselves what adds to negative 12, or multiplies to negative 12 and adds to negative 4. So that's going to be 6 and 2. The difference between 6 and 2 is 4. And then multiply to 12. And our bigger number should be negative. So this is u minus 6 times u minus u plus 2 is equal to 0. Okay? So now we just set this equal to 0. So u minus 6 equals 0, and u plus 2 equals 0. So u is equal to 6, and u is equal to negative 2. Okay? So now we can go back in and substitute our x squared for u. So u equals, I'm just going to rewrite this up here. U is equal to 6. U is equal to negative 2. We're going to substitute in x squared for u. So this becomes x squared equals 6, and x squared equals negative 2. So we can take the square root of both sides. We get x is equal to plus or minus the square root of 6. If we're looking for all of our real roots, that's our solution set. X squared minus 2, there's no real roots to that, but we can find the imaginary roots to this. So we can write this as x squared is equal to negative 1 times 2. So this becomes x squared is equal to the square root of negative 1 times 2. Well, the square root of negative 1 is I, and then we have the square root of 2. This is plus or minus. So if we're looking for all of the, I don't like that, plus or minus. If we're looking for the real roots, the x minus 6 is our answer. If we're looking for all the roots, including the complex roots, then we have to include this one as well. Okay, so again, we had x to the fourth and x squared, so we did a u substitution. U is equal to x squared. So we rewrote this in terms of u, and we factored as normal. Then we resubstituted in x squared for u and found our roots. Okay. Other types of equations that you'll see is equations with negative exponents. Let me just move this over. I got into my space here. Oops. we can see negative exponents. So when we have a negative exponent, there's a couple ways we deal with this. Again, we can use substitution. We can say that we can say u is equal to z to the negative 1. If we do that, we have 2, we can rewrite this as 2z to the negative 1 squared plus 11z squared. And we're going to just subtract 40 from both sides so that we're equals 0. Okay, now we're going to substitute u in for z squared. So this 2z to the negative 1 squared becomes 2u squared. Plus, this should have been z, I was one step ahead of myself, z to the negative 1, plus 11u minus 40 equals 0. So now we can factor this. This isn't a form that we know how to factor. We can do this one of two ways. We can do the AC method, which a lot of people seem to find helpful. So our AC is 2 times 40 is negative 80. So we need to find something that multiplies to 80 and has a difference of 11. So this is going to be negative 5 times 16. So we can rewrite this. This is 2u squared minus 5u plus 16u minus 40 equals 0. This becomes 1 times 2u minus 5. We're going to factor out an 8 from the second part, or this is u, sorry, u times 2u minus 5, plus we're going to factor out an 8 times 2u minus 5 is equal to 0. So we have u plus 8 times 2u minus 5 equals 0. And then we want to continue to solve this. So I'm just going to come up here. I'm going to say u plus 8 equals 0 and 2u minus 5 equals 0. So u plus 8, we're going to subtract 8 from both sides. We get u is equal to negative 8. We're going to add 5 to both sides of this. We're going to get 2u equals 5. Divide both sides by 2. We get u is equal to 5 halves. Now remember, our u was z to the negative 1. So that we're going to substitute that back in. So z to the negative 1 is equal to negative 8. Well, if you recall with our exponents, z to the negative 1, well, that's like 1 over z is equal to negative 8. And here again, z to the negative 1 equals 5 halves. So this is 1 over z equals 5 halves. So we just want to take the reciprocal of both sides. So z is equal to negative 1/8, and z is equal to 2/5. Okay. Same basic concept. We have a middle term. We have our leading term is a square of our middle term. We do a u substitution, and we can solve that way. Another way that they show in your book is that you can take this equation and you can multiply to get rid of all of your negative exponents. So we could have taken this equation and multiplied both sides by z squared. If we do that, we'd get, if we multiply everything by z squared, we get 2z to the negative 2 times z squared plus 11z to the negative 1 times z squared equals 40 times z squared. So z to the negative 2 times z squared, this just becomes 2. 11, again, when we multiply, we're going to add our exponents. So negative 1 plus 2 is 1. So this becomes 11z is equal to 40z squared. So that's just another way to deal with these problems. If you work through this and then solve this quadratic equation, you get the same thing. So whichever one of those works best for you, either the use substitution or multiplying by your largest, or so if it's z to the negative 2, we're going to multiply by z to the 2 to get rid of our negative exponents. You can do that. Okay, I am going to stop here and keep this one shorter. There will be another one. I just wanted to go through through fractional exponents. So we'll come back and take a look at this example. But this is quadratic equations in quadratic forms, and it's just a matter of recognizing things that we can manipulate to look like quadratic equations, whether it's higher powers or negative exponents, or in this case, fractional exponents. And I will come back, I'll put a second video on here with the fractional exponents. So take a look at that if you have questions, if you're struggling with those problems. Again, we're at the Academic Support Center at Raritan Valley Community College. During the COVID-19 shutdown, we are available through virtual meetings, online meetings, and when things finally go back to normal, we are on campus at the Academic Support Center, and we're here to help. So if you need help, please reach out.